Okay, so we're going to work on a problem today using a mixture. We're going to be looking at problem number 32, which you should be able to see on your screen. It says blending spices. Spice of Life sells ground sumac for $2.25 per ounce and ground thyme for $1.50 per ounce. Aman wants to make a 20-ounce za'atar seasoning blend using the two spices that sells for $1.80 per ounce. How much of each spice should Aman use? So let's take a look. So the first thing we're going to do is set up our picture to look like what we're actually doing, which is we're adding two spices together coming from two jars. We're going to mix them into one jar. So those are my jars or bowls. So the first one is the sumac, which I have no idea what spice that is, but it sells for $2.25 per ounce. So OZ is the abbreviation for ounce. And ground thyme, so this is the thyme, and it sells for $1.50 per ounce, $1.50 divided by 1 ounce. And then we're going to end up with a mixture over here of the two spices. The two spices, we know that we want to sell it for $1.80 per ounce. Now, if we set up the problem, we know that the total number of ounces of the sumac plus the number of ounces of thyme should be the number of ounces of the mixture. So let's let S equal number of ounces of sumac, and T will be the number of ounces of the thyme. And we're told that we want to make a 20-ounce blend. So adding these two together should equal 20 ounces of the blend. So that gives us the equation S plus T equals 20 ounces. Now the value of these should also be equal. So basically we should be able to say that the cost or the price or the value of the sumac plus the value of the thyme should be equal to the value of the mixture. Well, how much is the sumac worth? Well, it's $2.25 an ounce. So if we had 2 ounces, that would be 2 times $2.25 or $4.50. We don't know how many ounces we have, but we know we have S of them. So we're going to make this 2.25, the price per ounce, times the number of ounces S, plus the price per ounce of the thyme is $1.50 times T. And when you add those two values together, you should get the value of the mixture, which is $1.80 per ounce. So $1.80, but we know how many ounces of that we have. We have 20 ounces. So this is $1.80 per ounce. And notice that the ounces will cancel and we get left with money. So money plus money equals money. Now we have two equations and two unknowns. We can solve this system of two equations by substitution. We could also use additional elimination. You could do graphing, but it's not a great option. So I'm going to do substitution with equation number 1. Equation number 1, I am going to be looking for S. So I'm going to solve for S by subtracting the T from both sides. So that gives me 20 minus T. And I'm going to substitute that into equation 2. So when I put it into equation 2, and this is my equation 2, I have 2.25, open up an empty hole to put in my substituted value, plus 1.50T equals, and now I need to figure out what is $1.80 times 20. Well, $1.80 times 20 would be $36. So this gives me, that's a pretty expensive spice, but that is, I think, what it would end up being. 18 times 2 is 36. The 1 0 would move the decimal point 1 place to the right, and that gives us 36. So now I'm going to substitute in place of the S, I'm going to substitute 20 minus T. 225 times 20 would give me, so this would be 45, because if I double 225, I get 450, but then the 0 would move it 1 decimal place. So I have 45 minus 2.25T plus 1.50T equals 36. Now, if I combine my two t values and I move my 45 by subtracting the 45, this will give me a negative value, but that's okay because my t is going to be negative. And that way, when I end up, I'll have the negatives be divided out, and then I'll have a positive. So this is going to give me the negative 2.25t plus 1.50t is a negative 0.75t, which is equal to a negative 9. And when I divide both sides by negative 0.75, I can come up with the value for the number of ounces of time. Thus, time is equal to 12 ounces. Let me do that. And then how would I find the value for S? Well, I've already solved for S. I'm up here when I was looking at equation 1. So I use equation 1 to find S. S is equal to 20 minus t, but I know t is 12. So that means that S is 20 minus 12. So it must be 8 ounces. That's the first example we want to do of a mixture. I'll do one more mixture problem, which is number 33, and then we'll move on to distance rate time problems. Now we're going to take a look at problem number 33, an acid mixture. Jerome's experiment requires him to mix a 50% acid solution with an 80% acid solution in order to create 200 milliliters of a 68% acid solution. How much 50% acid solution and how much 80% acid solution should he use? Complete the following table as part of the translate step. So they're having us use a table on this one. We'll use the table, but we'll also use the picture to help us get an idea of what we're doing. So let's set up the table and the picture right now. You can see on this sheet of paper that I've recreated the table, but I've also drawn a picture of what we're doing. We're taking two beakers, one containing 50% acid and one containing 80% acid, and we're going to mix the two together into one combined container of 68% acid. So if we fill in the parts of the table that they've already mixed in, they want us to basically take X amount of the 50% solution. That means that I might measure out exactly X milliliters of that solution. And they want us to take Y milliliters of the 80% solution. And when I mix those together, I should end up with 68% of the acid solution. So this is probably in milliliters or something like that. It doesn't actually, yes, it does say milliliters. So we know that we're going to take X milliliters of the first one, and we're taking Y milliliters of the second one. Well, if I mix X and Y milliliters, I should end up with the total number of milliliters, which they tell us in the problem is 200 milliliters. And that gives us our first amount. When we're done, we should have 200 milliliters of liquid. That's not the pure acid, that's just the liquid, the total liquid, which includes the water, whatever's diluting it, and the acid as well. So our first equation that we can set up is X plus Y equals 200. Now we need to talk about the percentages. We know that the percent of acid on the first one, this one is 50% acid, this one is 68% for the mixture, and this one is a stronger solution of 80% pure acid. Now when you're talking about a percentage, the percent symbol, remember, means per 100 or divide by 100, which would convert these into decimals. So we could also think of this as 0.5. We could think of 80% as 0.8, but the 68 would have to be 0.68. Now, how much pure acid is in each container? If you're talking about having, let's say, 10 milliliters of solution that's 50% acid, then 50% of the 10 milliliters is pure acid, or 5. How'd I get that? Well, I multiplied the 0.5 by the 10. So the amount of pure acid that's in the container has to be 0.5x. That means that the pure acid, which is what I will write down here underneath the symbols of the beakers, this one has to be, if this is our 50% solution, and this is our 80% solution, and our 68% mixed solution, this would have to be 0.5x, this would be 0.8y, and this would be 0.68 times the 200 milliliters. Now, filling out the table, this would become 0.8y, and this would again become 0.68 times 200. However, you cannot create pure acid just by mixing them. So the amount of pure acid in the first container added to the amount of pure acid in the second container has to equal the amount of pure acid in the result. And this gives us our second equation. So now we need to figure out what is 0.68 times 200. Well, 0.68 times 200 would give us 136. So that's our second equation. So here's equation 1, and now we're going to write equation 2. 0.5x plus 0.8y equals 136 milliliters of pure acid in the mixture. These two equations up here form our system of linear equations. Again, I could use the addition-elimination method or substitution. I could even graph them. The graphing is usually not the best option. I'm going to do substitution again. So I'm going to take from equation 1 and I'm going to solve for x. So that would give me x plus y equal 200. I need to subtract the y from both sides. And that tells me that my new equation is x equals 200 minus y. Now I substitute that found value into equation 2. When I substitute it into equation 2, I need to open up a hole where the letter x, the variable x, was before, but only the x, not a sign, not the coefficient, not a power, nothing but the letter itself. Then I add plus 0.8y equals 136, and I drop into the hole the 200 minus y. When I multiply this out, 0.5 times 200, remember 0.5 is half, it's 50%. So half of 200 would be 100. So I get 100 minus 0.5y plus 0.8y equals 136. I'm going to move the 100 to the other side and combine my two y terms, which are already on the left. So I move the 100 by subtracting. And the 0.5y plus 0.8y gives me 0.3y, which is positive because 0.8y was positive. 136 minus 100 is 36. Now I need to divide both sides by 0.3. When I divide by 0.3, this tells me that y has to be equal to 120. So we have 120 milliliters of the 80% solution. So we're going to use 120 milliliters. 80% of that 120 milliliters is pure acid, but this is the amount of the mixed stuff. So some of it is the diluting agent. Now, how would we find the x value? I can return to where I solved for x out of equation 1, and I know that x has to be 200 minus y. So on the next sheet of paper, that means that x has to equal 200 minus 120, or x is 80 milliliters of the 50% solution. That's the end of this mixture problem.